Hello guys! In this video, we are going to talk about the first and one of the most important steps of any machine learning project, which is preprocessing. As Ruth Porat, the CEO of Google and Alphabet said, the most valuable thing you can have as a leader is clear data. In fact, data is the most important asset in the world these days. Everything depends on data, from machine learning systems to marketing, down to decision making. Most of the times, you will get data not in an organized way. It means you will get most of this data in raw format. It contains many errors, which makes it incomplete. You can make it predictable or useful by transforming the raw data into an understandable format. But to transform the data, you have to know the different data preprocessing steps. In this video, you will learn what is data preprocessing and what are the various steps you will take while doing data preprocessing. So friends, let's get started. So what is data preprocessing? Data preprocessing is a data mining technique that involves transforming raw data into an understandable format. Why we do preprocessing? Real-world data is often incomplete, inconsistent, and lacking in certain behaviors or trends, and is likely to contain many errors. Data preprocessing is a proven method of resolving such issues. Now, when we do preprocessing, in the real world, you will see most of the data are noisy. It contains many errors, making it unstructured data. In order to transform the unstructured data into structured data, you will use data preprocessing steps. Therefore, when you have a raw data, you will definitely use data preprocessing. Now, what are the data preprocessing steps that we are going to learn in this course? We are going to learn missing data handling, categorical data handling, normalization, and standardization. So let's start with missing data handling. When you import a dataset, you might find that there are some missing values inside of it. If it's not corrected, then it will be difficult for you to get a good results of your machine learning model. Replacing the missing values can be achieved by two methods I am describing here. The first one, if you have a large dataset containing huge information, then you can delete the row of the data having the missing values, but it will have a negative effect on getting accurate results or predicting the output. The second and recommended one is imputation. Suppose you have a numeric column in your dataset. It have null values. Then you can replace the missing values with calculated mean, median, or most frequent of entire rows values of that particular column. The second type of preprocessing is to handle categorical variables. Categorical variables are basically the variables that are discrete and not continuous. For example, the color of an item is a discrete variable, whereas the price of it is a continuous variable. Categorical variables are further divided into two types, ordinal and nominal. The ordinal variables are variables can be ordered. For example, the size of a t-shirt. You can say that medium is smaller than large and large is smaller than x large. The second type is nominal variables, and these variables can't be ordered. For example, a color of a t-shirt. We can't say that blue is bigger than green, as it doesn't make any sense to compare the colors as they don't have any relationship. Now we have two techniques to handle categorical variables. The first technique is label encoder, which encodes a set of features values into numerical data. As we see in this example, we have a color feature with the values red, red, yellow, green, and yellow. After applying label encoder, we have now the numerical features 1, 1, 2, 3, and 2. Now label encoder transformed red to 1, and yellow to 2, and green to 3. The problem here is since there are different numbers in the same column, the model will misunderstand the data to be in some kind of order, but this isn't the case. To overcome this problem, we will use one-hot encoder. In one-hot encoding, what we essentially do is that we create n column where n is the number of unique values that the nominal variables can take. So in our example, if color can take red, yellow, and green, then we will just create 3 columns, namely color red, color yellow, and color green. And if the color is red, then the values of color yellow and color green columns will be 0, and the value of color red will be 1. So out of n columns, only one column can have value equals to 1, and all the rest will have values equal to 0. Now let's talk about normalization. In most cases, normalization refers to the rescaling of data features between 0 and 1, which is a special case of min-max scaling. In the given equation, we subtract the mean value for each feature from each feature instance and divide by the spread between max and min. In effect, it measures the relative percent of distance of each instance from the mean value for that feature. So why we do normalization? In fact, it can lead to an increased speed of learning. It's also useful to ensure that our inputs are roughly in the same relative small range, to avoid problems which computers have when working with very small or very big numbers, which is known as numerical overflow. Now let's see an example of normalization. Let's suppose that we have a dataset of housing, and one of the features is house price. We notice on the left histogram that the house's price is between 100 and $500,000. By applying normalization, the range now is between 0 and 1. The last preprocessing technique that we are going to learn in this course is standardization. Standardization is a popular feature scaling method which gives data the property of standard normal distribution, also known as Gaussian distribution. All features are standardized on the normal distribution, and the mean of each feature is centered to 0. Also, the feature column will have a standard division of 1. Now let's see an example of standardization. In this example, we have 2 datasets with different mean and division. By applying standardization, we notice that both datasets now have mean of 0 and division of 1. You may ask when you should normalize and when you should standardize. There is no definitive answer to this question, but usually, if your dataset is not too big and you have time, you can try both and see which one performs better for your task. But if you don't have time, as a rule of thumb, unsupervised learning algorithms, in practice, more often benefit from standardization. Standardization is also preferred for feature if the value of this feature takes a distributed close to a normal distribution. Standardization is preferred for a feature if it can sometimes have extremely high or low values, which are known as outliers. This is because normalization will squeeze the normal values into a very small range. In all other cases, normalization is preferable. So that's it for today's video, and see you in the next one.